What's up, guys? So how do you use ZPP? That's right. Remember, ZPP stands for the zero product. Whoops. We don't need that extra P in there, do we? Product property. The zero product property. Remember, the ZPP was this. After we factored a trinomial or a binomial, whatever, and we had these two factors, what you could do with the zero product property is you can take the first factor, or however many factors there are, one of the factors, and say, let me set that factor equal to 0, the zero product property. And then I could take the other one, 2x minus 3, and set that equal to 0 as well. What do you do now, Mater? You solve it. So just subtract 4. So that means one of my solutions to this particular equation would be that x equals a negative 4. Or the other scenario was when I add 3 over here, and then you divide by 2. So one of your other possibilities would be that x would be equal to 3 over 2. So there's your two situations. You take the factors, whatever they are, the binomials, or the trinomials, whatever they happen to be, set them equal to 0. That is ZPP, zero product property. So how does that apply with what in the world we're doing in class now? Well, here's how it applies. Let's take this simple example, which you can write on your graphic organizer right there. This simple example, let's talk, Mater, and let's use it to find the real number, so that's going to come into play in a little bit, the real number solutions of this particular equation. So we want to know what we can plug in here, as always from pre-algebra or even algebra 1. What can I plug in for x that would make this equation true? Well, some of you, many of you might be able to look at this and know exactly what the answers, notice what I said, answers, there's not one answer, there's two, what the answers actually are. But here's the first thing, let's do this. First of all, if there's any GCF, of course we need to do that. But let's do this, let's factor it. Well, I see it's a binomial, and I see it's actually a difference of two things that I could rewrite as something that's squared, like such. So this guy would factor into, very nicely, x minus 2 and x plus 2. It's the difference of two squares rule that we talked about many times and practiced many times. So I've now factored that. What do I do now? Well, since it's asking you to solve and find the real solutions, I must now do the ZPP. Yeah, you know me. So I'm going to take this thing, and I'm going to make that thing equal to 0, so x minus 2 equals 0. And I'm going to take this thing and set that thing equal to 0 and go x plus 2 equals 0, and then just simply solve these two little equations, which would mean one of my possibilities would be x equals a 2. There's one of my real number solutions, 2. Or when I subtract 2 to both sides, I get x equals negative 2. Beautiful. So there would be your two solutions to this particular quadratic polynomial function equation, whatever you're talking about. So beautiful. So that's a simple example. That's easy. Let's go over now to this one where it's a factor by grouping example. Directions are still the same. Let's find the real number solutions to this equation. Well, what's the first step? GCF, if there is any in all four of these. I don't see a GCF in all four of them, so let's do this. Let's factor. How do we factor it? Well, it's a four-termed polynomial. So that's why I say factor by grouping. So let's do it. Factor by grouping. Let's take this first set of things, group them together, factor out the GCF, which happens to be 2x squared. When I factor out that, that gives me x plus 9. That's nice. And then when I take the second group of things, factor out the GCF of that, it looks like a negative 5. I got to factor out of that. And that gives me, let's see, negative 5 times x gives me that. And then I need a positive 9 right there to give me negative 5 times positive 9 to give me negative 45. And all that still equals 0. So there we go. So we're not done factoring yet. This is still the factor by grouping. But I have my checks and balances done because I have this x plus 9 and x plus 9. So that's the same. Yeah, check baby 1, 2. That's cool. So let's keep on going. So that means this 2x squared and this negative 5 become my first set of parentheses. Yeah. And then that means this. The other ones, x plus 9, become my second set of parentheses. My second binomial. So there you go. So we factored it. Check baby 1, 2. Now we got to use the ZPP to solve this. So that means I take 2x squared. I'm actually going to come over here. I'm going to take 2x squared minus 5, set that equal to 0. And then I'm going to take the other one, x plus 9 equal to 0. Well, let's solve this one on the right first. It's a little easier. I subtract both sides, subtract 9 from both sides. That gives me x equals negative 9. So there's one of your solutions. Now over here, oh boy, notice this. This goes back a couple moons ago now. Haha. I have just one visible x squared. There we go. What does that indicate to you? That's right. We're going to use the square root method to solve this bad boy. Remember, that means this. I got to get this thing right here by itself first. Again, we're just simply solving this little equation over here for x. So, I'd add 5 to both sides. That leaves me with 2x squared equals 5. Beautiful. Now I got to divide by 2 because I got to get the thing, again, that's squared by itself. So that cancels out. So now I'm left with x squared. Lovely. 5 over 2. Alright, oh boy, here we go. So, now that I've got the square thing by itself, now with my square root method, remember, I must take and square root, beep, 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 both sides to free my variable from the squared. But remember, oh yeah, there's that plus or minus we have to put in there too. Don't forget, it's a plus or minus when you do square root of both sides. So these cancel out. I'm left with x equals plus or minus, ew, yucky, plus or minus root 5 halves. Root 5 over 2. Square root of 5 over 2. Now, that means, oh looky there, you have 3 answers. So either it's x equals negative 9 or x equals positive square root of 5 over 2 or x equals negative square root of 5 over 2. Now remember, we talked about this in class. I would still take this particular square root and rationalize it by taking root 2 over root 2 and getting 5, whoops, as we did in class, by doing the square root of 10 over 2. So there would be one of your answers, positive 10, positive square root of 10 over 2. Or when you do the same thing over here, you'll get negative square root of 10 over 2. So technically, those right there are 2 of your answers, along with this negative 9. Do they always come out to be like this, where it's a square root of a fraction? Nope. But it's still the same concept. Understand the deal. Factor it first. Get your factors over here. And then take ZPP and set them equal to 0, and then solve them accordingly. Okay? Let's do one more. Let's do one where it's actually the sum or difference of 2 cubes. This happens to be the difference. So again, back to this. It's real number solutions. So this real number solutions is going to come into play with this example, you'll see. Because we're only looking for this real number ones. This one's going to generate some imaginary solutions. That's right, square rooting negative stuff. But we only want the real number ones. So, regardless, if it's sum and difference of cubes, if it's factor by grouping, if it's just straight up a factoring one, the first step is always factor. First step was always factor. Same thing here. Let's factor this thing. How do we factor it, Mater? That's what we just practiced megally in class. Remember this thing right here. Let's write it as something cubed. Let's take 27 and write it as something cubed. Can I do that? You bet. I can write an x there, and I can write a 3 there, because 3 cubed gives me 27. So this will factor into, remember, my general framework. It stays the same. I match that sign. I then do opposite that sign, and I then do always positive. Always positive, always positive, the last one. And then I'll put this in here, parentheses. So over here, I'm going to square whatever it is. I'm going to put this there. I'm going to put this there and square that. So remember, A goes there, B goes there. A goes there, A goes there, B goes there, B goes there. So I'll take my X, which is my A, and I'll put it in there, there, and there. And I'll take my B, which happens to be the 3, and put it in there, there, and there. Ooh, that looks pretty cool. All I need to do now, remember, is clean it all up. So this whole thing over here will go to just simply x minus 3. That's no big deal. Oh, don't forget the equals 0. Sorry. That always comes down. And then this just is x squared. This is 3x. And this is 3 squared, which is 9. Beautiful. Equals 0. Okay. So we factored it. Check, baby, 1, 2. Now what do we do, Mater? Oh, we do the ZPP. So I take these two factors. I'll take x minus 3. I'll put it up here. and I set that equal to 0. Let's do this a while because it's easy. I add 3 to both sides, so one of my possible real number solutions will be x equals 3. And here comes the thing that you want to slow this down a little bit and make sure you write this down, because when you set this thing here, this whole trinomial equal to 0, I'm going to tell you, with sparing you the details, every single time, I hope you write this down and start, every single time when you solve this thing right here for x, you're going to get an imaginary, well, spelled wrong, solutions over here. Always. Always. So what are you saying, Modern? That means this. Anytime you have the sum and difference of cubes, yes, you factor it, you betcha. Yes, this is still important to factor it, you betcha. This is absolutely important to do that. But the only answer that you're ever going to have that's a real number solution to this particular sum and difference of cubes is the binomial. You're only going to have it be x equals 3. And that's it. These over here will give you solutions, but it's going to be imaginary solutions. Okay? Let me graphically show you how this actually all comes about. You'll see that there's only one real solution. Whoa, sorry. There's only one real solution for this sum and difference of cubes. There was actually 3 real solutions for this factor by grouping, and then there was 2 real solutions for this one. Check this out. So remember when we graph these things, whether it was a parabola or a Z shape or a W shape or any of those things, when we went back to the first part of the year, when we graphed these and found solutions to like the parabolas, it was where the actual graph crossed the x-axis. Those points of intersection, guys, was the solutions, the real number solutions to the equation. So I'm going to show you this. Check this out. As you recall, what we just found for this x cubed minus 27, you can see how it's graphed here. Should make sense. It's an S-shaped thing. Yep. Now I had to zoom way out on this so you can see the S shape. But what I want you to notice is this. It only crosses the graph at one point, right here. And check this out. Whoops. Whoops. Check this out. Look where it's crossing. Oh yeah, at 3. Let me get rid of that one. Watch this one. Back to the factor by grouping. Remember we had 3 possible solutions to it? 3. Check this out. Oh, it crosses at 3 different places. It crosses at 1.58, negative 1.58, and negative 9. Go look at your answers. It's exactly those. That's the real solutions. It crosses the x-axis. Really it does. Real solutions at 3 places. And remember this one, x squared minus 4, it crossed, well, it had 2 solutions, so you're going to see it crosses twice. Oh, look at that. Let me zoom in a little more. Check out what the answers are. Look where it's crossing. That's right, it's crossing at 2 and negative 2. The actual solutions to the equation. Ha! You're welcome, guys. Rock and roll. We're going to practice these things in class where we continue factoring. We're going to continue honing our skills on factoring sum and difference of cubes and factor by grouping. And then going a step further with ZPP. We'll see you in class. Later. Peace.